talk today, and one of the main value propositions about DAMA International is that we have to turn data into money. Now, that sounds very crass to start off with, but our managers care about one of four things: faster, better, cheaper, or less risk. And so everything that we do in data has to somehow map up to these pieces. And for years and years, I heard people saying, well, it's very difficult to do this. And the answer is yes, but as soon as you start to practice, it becomes easier. And I'm very old. I have a long career at this. And my lifetime total for this is 1.5 billion US. That's a very big number. And I'm going to show you some of the ways we've achieved this number. But most importantly, we're here to help you all learn those techniques so that you can take them and apply them in your own organizations. So I'll just jump right in and start off with perhaps data governance. Most of you are familiar with data governance, yes? Okay, right. Well, this is what we call a complex data governance approach. It's not necessarily good or bad, but we're doing this one for a large city. And I want you to imagine the politician that's in charge of the city, the mayor of the city, and saying, oh yes, well we do some of this, and then these guys do this, and then this is here, and then we go over to here, and how long is the politician going to pay attention to this? Very short amount of time. So it's a very complex subject, and it's important that we as data professionals know how to communicate. And the way we communicate best is by saying one of the following: faster, better, cheaper, or less risky. And the reason we have to do that is because data is a very complex subject. We think of it as like the blind people meeting the elephant for the first time. Most of you have heard this story. Somebody looks at it and says, oh, the ears are like a fan, or the trunk is like a snake. Get the picture here, right? Well, data is very much the same way. It's a warehouse, it's a dashboard, it's pipes, it's a story. None of these are wrong, but all of them are correctly different. And so it's hard for us. And unfortunately, for whatever reason, our college and university systems worldwide have fallen down on the job. Now, I'm a college professor, so I'm allowed to say bad things about colleges. Again, I don't know anything specifically about your education system here, but I have been on accreditation boards and looked around, and even my own university is not really good on this. What happens is our knowledge workers, not just our data professionals, but our knowledge workers around the world all deal with data. Everybody okay with that? A knowledge worker has to be dealing with data or they wouldn't be. And a knowledge worker is somebody who makes money with this part of their body instead of this part of their body, which is a labor worker, right? Well, the problem is they go out and they learn how to do data all on their own. And this is one of my favorite little stories. This is a guy named Wally Easton who was told to go learn to play the piano. Yay for Wally, right? On the other hand, if quality was his goal, yeah, maybe he didn't make it, right? All of your knowledge workers in your organizations are learning how to do data on their own. And they're coming up with things that are equally as creative, but probably not as useful to the organization as they want. There is lots and lots of untapped productivity in finding out how these organizations, how the knowledge workers in them do this. So the question is, what do we want our knowledge workers to become good at? And the answer, of course, should be, if we do data better, everything will be easier. Never easy, we're not promising that, but easier is a good thing for most organizations. So the concept of monetization is the idea of taking something that's conceptual and turning it into something that is useful. Google did this 30 years ago, turning searching into money. Of course, what is it? It's monetizing our searches and handing that money off to companies, and then we get little things like surveillance capitalism, which is not necessarily a good thing around that. Now, when we talk about governance in this context here, what we look at is that there's some data leadership And they have some feedback, but it's kind of vague, and we're not really sure where everything is coming and what's happening here. Eventually, they become associated with one of our chapters or one of our professionals, or somebody has read a book or heard a webinar or something and say, we should do data governance. And that's good. That improves data over time. The question is, how long? And in many cases, data governance is perceived as a slow approach. It's the idea that we'd like to change the quality of the water, but of course we can't do it right down here where all the bridges are. We have to go upstream in order to actually make the water better. Same thing with data. So we can learn a little bit about this, and over time we'll do that. But most of the time what also happens is our organizations say, I can't wait years for this, so I need something to happen faster. And in order to do that, we start with data improvement projects, data quality exercises. And data can be faster then as a result here. Not that, slow and fast are the only two options, but management kind of thinks fairly simply all the way around. As this goes, our feedback becomes better, and we understand more about what's happening in our environment, and we can do more things to set it up. And we set up a standard data governance structure with data stewards and things like this. Now, I will give you all copies of these slides to make sure, so you don't have to worry about trying to catch them because they go by very, very fast. I saw, my colleague told me too, I should also mention, we did not steal your coats. If you put your coats on the racks, we've got a coat rack now that's hanging up behind the registration desk. So. The key here, though, is as data professionals, we have to get good at celebrating when data things happen, but we also have to become good at saying when a data thing happens, here's the thing that happens in the organization that management pays attention to. And that's the important link. And this is just a matter of practicing here. So once we start to do this, oh, great, I cleaned some data. That's nice. Oh, great, I cleaned some data, and now I can sell more product. Now we're starting to get to where management understands. So we've got to go that extra step to make sure that we understand that we can communicate the business value into our folks that we're working with. There are a lot of different story types around this. Again, clean some data. Well, if I decrease the number of undeliverable advertisements, yeah, that's a better way to say that. Or if I reorganize the database, oh, that's very nice. Nobody wants to talk about that. We do, of course, but I'm talking about the rest of the business. But if I increase the ability of the sales force to perform their own analysis, that's good, right? If I develop a taxonomy, thank you. Yes. But if I get everybody on the same sheet of paper, I would assume there's some musicians in here. Yeah, okay, a couple, right? Important that we're on the same sheet if we're going to play the music, right? So, again, that common vocabulary can be very important. Oh, you optimized a query. Very good, little boy, right? What does that mean? Well, if I shave 1 second off a task that occurs literally 1 billion times a day, that adds up to some things very, very quickly. And finally, let's reverse engineer the legacy database. Again, what? Well, every old system has something good in it and something bad in it. We need to formally identify the things that are good and make sure they are repeated in the new system. And we need to identify the things that are poor and make sure they don't become part of the new system as we go out there. Now, I took great inspiration in figuring out how to do this from a wonderful book from a guy named Douglas Hubbard. And the idea here is how to measure anything. Even though I have written 13 books, I've sold more of his books than my own. It's okay, it's a better book, right? But what he says is measurement is not really about precision, it's about reducing uncertainty. Very good change when you look at this. When you formalize stuff, it forces clarity in our organizations. Whatever your measurement problem is, somebody else has already done it. So Google it and find out what they did so that you don't have to reinvent the wheel as you're doing this. For any measurement, you generally need less data than you think you need, and you have more data than you think you have. It occurs in almost every case. And you probably need some different stuff anyway. So Enrico Fermi was one of the fathers of the atomic bomb in this, but he used to teach classes in Chicago. And this is an exercise from the book that is described. And what he would say to people is, you are my class now, and you can't leave this room until you tell me how many people are piano tuners in the city of Chicago, Illinois. That's where Kathy is from. By the way, you can't use the Yellow Pages or Google. Oh man, this is going to be hard, right? Well, turns out in the 1930s, the city of Chicago had 3 million people that were involved in it. And of that, the average number of people in a household was 2 or 3. Interesting numbers. These are things that we can ask each other and find out. And the number of households with a regularly tuned piano, if we just went around the room, we could find out the answer there, 1 in 3. Okay. And how often does a piano need to be tuned? Once a year under normal circumstances. And how many pianos can a piano tuner tune on a daily basis? 4 or 5. Now, how many days a year do we work? 250. I think we have all of the ingredients at this point, which means the equation for the number of piano tuners in Chicago is the population divided by the people per household times the percentage of households with tuned pianos times the tunings per year divided by the tunings per tuner per day times the number of work days per year. Is this the right answer? It's closer. Again, we're going for easier, not easy. But now when I have these numbers, I can argue about whether these numbers are correct. This is the formalizing stuff, forces clarity around this. Now, you know, as we're doing this, we always use lots of cartoons, and sometimes we pay for them. This is one I paid for, so I'm very proud to show it to you all. This is somebody named Sheena, who's driving to the airport so slowly that she's caused 120 drivers to lose 5 minutes apiece. You can do some math, right? 120 divided by 60 is 10 person hours that we've lost in this. And she's the person at the security check-in point who forgets to take the laptop out of the case, so it causes, again, another 40 people to lose 3 minutes apiece. And of course, when we're connecting as we're going through Amsterdam, she's the person in first class who's pulling on her bag and can't get it out. Meanwhile, you have 360 other passengers waiting to get past her to make their connections. Well, again, we can add up these numbers, and on a whole day, she has killed an entire person. Good cartoon. So knowledge worker productivity is really important. Even if we can remove 1 click from a repetitive task, we can tally the number of clicks that occur in our organization and then assign some sort of value to that clicking process. This is just one of many, many techniques that are out there, but it's pretty easy. I'm going to give you a quick example from a bank that was willing to put their name on this. So this is an official bank statement that they went. And they said they had a new calculation they wanted to say. A new field E is equal to A plus B divided by C, where B is a customer record, and C is provided by a vendor, so they're getting some new information and they think they can fine-tune their algorithm a little bit. Well, they were, as usual, with almost any data project, and that's why we are employed gainfully. Some loans were missing field A, some were missing C, some were missing C, B, little incompleteness in here. And they went back and IT completed the project. Now, it's always fun to pick on IT because IT doesn't think of data first. And that's one of the things we hope to change as we're working through these pieces. But they went through and did some stuff and worked on it for months and months and months and went back in front of the executive. And the executive came back and said, how many loans were we able to calculate this new field for? And the answer was 43. Everybody okay with that being a disappointing number? Yeah, certainly less than half is not what you want to be working towards on this. And so the question is, why only 43? Well, we had bad data and we did everything we could, but we've reached the end of the project budget and it's time to deliver. This is where it's time to change our approach. And this executive said this. This is the executive up here in the corner, Linda Bevelo, and she works for First Bank in Chicago. So she says, let's go back and figure out what goes on. This is not what we expect to do in terms of the investment. And they went back and looked at some things here, find some alternate ways of calculating things, putting some more time and effort into fixing the challenges that they had. And they measured success differently. Same project, same process, different measures for success. Her answer to this was that she was able to come up with a very significant amount of money of $50 million annually. Now that's the kind of thing that will get somebody promoted. Like I said, most banks don't want to tell their stories in public. She was willing to tell her story in public in order to do this. Wonderful example of this. Let me give you another one. This is I live in the state of Virginia, which is below Washington, D.C. in the East Coast. And we had 10,000 workers in an organization that were doing this type of work. And what they were doing was keeping track of time records. And the organization challenged us to find $10 million in savings. So we got together and said, okay, well, this represents the number of employees. This represents the district the employees were in. And of course, this represents the pay grade those employees were at. Now, that means we can look and say, first of all, why do we have employees at high work grades that are doing clerical work? It's a good question. There's probably an overuse in there somewhere. But I also have a total of a large number of employees here, 300 employees, spending at least 15 minutes per week doing timekeeping functions. Okay, how much does this cost? Well, in order to do this, I don't have to go around and ask everybody, how much money do you make, how much money do you make, right? That's a very nasty question. I can go to the standard tables. Once again, just like the piano tuners, do I have the right number here? No, but I have at least this much money. They are at least an entry level on a table here of a grade 12 or a grade 6 or whatever it is. I can pull those numbers off very, very easily. And when I do that, I can look at some of the labor costs that come up. So I can calculate the number of employees, how much time they spend, what rates they're spending in terms of their weeks, and find out that, at least in this case, they're spending here doing time and leave tracking, 21,000 and 137,000. We add those two numbers together for one district, and we come up with all of these. We add the district numbers together, and I have $10 million very quickly. Everybody with me on this? These are things you can do in your organization to go and find money. And by the way, what value is coming from tracking time and leave? Most time and leave tracking systems say, I show up for work in the morning, I work my hours, and then I go home. Why would we write that down? We've actually had arguments about whether that should be collected or not as well. Here's another example. I'm going to pretend for just a minute that you all are PhDs in chemical engineering. Anybody in here a chemical engineering person? Why, as a matter of fact, we have two of them right here on the front row, right? It's funny how that works out. You'll get a chance to hear Chris a little bit later on this. So how much data management was in your PhD curriculum? That much, he says, right? Same? Same, okay, right. Now, everybody remember Y2K? And of course, many of you don't remember it, but those of us with the gray hair did live through the, absolutely. We had a big challenge around the fact that we were only using 2 digits to store the date. So why would a PhD in chemical engineering need to understand whether their product that they were using to store and manage data was Y2K compliant? What does that mean, right? Oh, here's what it means. These guys are making billions out there in the marketplace, making all sorts of additives for their fuels to make their engines stronger, the fuels burn cleaner, et cetera, et cetera. It was kind of a fun exercise because when we told the staff that they were going to be working with them and they needed to wear lab coats, they're thinking, healthcare, cool, right? No, when these guys want to make a test, they have engines running in the basement and they go downstairs and they start a test. And these tests cost them up to $250,000 each year. That's a very expensive process in terms of doing that. So we went through and created a process flow diagram, very interesting. Actually, management looked at this and went, you're done. And we said, what? They said, we've never understood what it was you guys, as 100 PhDs with chemical engineering, did to come up with value. We said, oh, okay, well, this is a diagnostic tool. It's not a documentation tool, but of course it can be used for both purposes. That's very nice. We wanted to point out some things on here to say that actually you guys, and let's, by the way, say that each PhD in chemical engineering in this room is getting paid $100,000 per year. Okay, so that's a $10 million a year investment in this. And we had PhD number 1 who was taking digital data on computer number 1 and turning around and re-entering that digital data on the second computer. Anybody in this room could have solved that problem for them. But again, as PhDs in chemical engineering, you're taught different skills, and that was not part of the base skill set because it was. Second thing that we discovered was that there was lots of USB ports being shipped around and people moving things around on USBs. The problem, of course, is that a USB sits in somebody's pocket, and if you decide to go on vacation, you can't actually make sure it gets to your colleagues, so the workflow stops. Get the picture, right? We also had lots of duplication in there. I'm just going to copy it to a spreadsheet, and then we have, what version of the spreadsheet are you using? Oh, that was last week, so which means I have to go back again. You get the picture. Synonyms. Yeah, sometimes we use words differently, and the same word can mean different things to different people. These caused problems around the organization as well. There were tribal knowledge requirements. Everybody, of course, knows Excel, right? How many of you, when you were learning Excel, were also taught that there's a capability in Excel that will always repeat your results perfectly? A macro. Fewer of you, right? Though some of you did, that's great. That's wonderful. Shouldn't we teach everybody that learns Excel macros as well? Just seems a little bit. And of course, the final part of this was they were using non-sustainable technology. They didn't know that Microsoft had never made FoxPro Y2K compliant. Ouch. Yeah, why would they? Again, part of your basic training as PhDs in chemical engineering? Not at all. This is, of course, repeatable in each of your individual domains. You have lots of experts that can do this type of work, but that type of work does not necessarily involve how to manage the data and how to add value to your organizations as a part of this. So, of course, we finished all of this and did the standard business improvement projects, and here's the number. Management said out of this $10 million a year investment in you all, they were able to make you all $25 million a year more productive as a result of these small, tiny improvements that were made all over the organization. Again, helping everybody to do work faster, better, and cheaper. Make sense again? Are you guys seeing the patterns here? Can you apply these patterns in your own organizations? Yes, of course you can, right? Another example. This is a logistics company, one of the top ones, Fortune 450 up in the very top. And once again, I notice a room of 100 people, only in this instance, it's this kind of crazy room here where there's paper throwing around and people are doing all kinds of things. And they had asked us to come in to help get them off the mainframe. Nobody's ever heard that before, right? Well, that just means that somebody sold them on cloud services. Now, I'm going to take a slight deviation here. The number one problem for CEOs worldwide is how to reduce their cloud bill. That's a big failure. We have had an absolute problem because all the vendors told us cloud's free, right? Didn't work out that way, did it? Now, mostly that should be a CIO or a CTO or a CDO problem. It should be somewhere lower in the organization. The fact that it is the number one problem for CEOs means it's a real big problem. Of course, these guys were sold the same bill of goods, yes, but what happened was every invoice that they were going to send out to their customers had bad information. The customer's name was spelled wrong, the amount they were charged for the service was wrong, the type of service was incorrect. And they didn't want to go out with egg on their faces, so they had this room of 100 people who spent all their time fixing all of these invoices. And of course, we said, you know, there's a better way to fix that. And the manager in charge of the room said, I just had the best quarter of the best year that I've ever had. And I'm thinking of doubling the number of people in this room next year. Now you laugh at that and say, yeah, we could fix that in many better ways. But here's the kicker. when the manager wouldn't pay attention to this, that's what you hire consultants for, to come in and give the bad news to somebody else. So I went to the CFO, the Chief Financial Officer, and had a conversation with her, and she said, oh, if you can fix that data quality problem in less than 1 month for less than $750 million, it's a positive return on our investment. Smart cookie, right? Absolutely. So what should we do? Keep pouring money into fixing things, or go back and fix the problem at the source? The answer, of course, is let's fix the problem at the source. Now, in the point of doing this problem, here's what was really happening. The organization was doing all kinds of really good work around this, but they'd hired a company to come in and write the code that was on the mainframe in Java outside of the mainframe. So it's a little bit older. Today we'd be rewriting in Python, which again makes equally no more sense, but they were still doing this. And they had a standard straight-through processing with a workflow event manager and an exception manager. But here was the interesting part. Somebody kept saying, who's going to do the data? And that's where they eventually called in the data consultants and said, come in and help us, please. We went out and looked and said, oh my goodness, they haven't yet finished this module, and they've spent 85% of the dollars they had allocated for the project. Can anybody predict what's going to happen here in the future? Yeah, they are out of money, and this project is a disaster. It's what we call a runaway train or something along those lines. Again, millions and millions saved here in this particular instance. Another instance. Now, I know I'm here in Prague, and you guys got through World War II okay, but we had a little error where the US accidentally bombed Prague. Sorry about that. Right? I think it only happened once, right, if I know my history a little bit on that, so that's good. Well, this was the group that did it. This is our Defense Logistics Agency. They're the people who tell where to go and what to do. Okay. A little bit later in history. This is recently. They had a challenge where they had lots and lots of data in a database, but the data in the database was in what we call clear text fields, comments fields. If you know anything about databases, that's not the way you're supposed to use databases. But nevertheless, for whatever number of reasons, which could involve how they make mistakes like that and things that happen, this is where the data was. And they're thinking, I've got to move it to SAP. Again, we'll forget about the fact that that's not necessarily good or bad solution. It's good software, right? But they were going to move it, and they were going to have to go in and examine every data field and figure this out. So the original approach was to go in and do manual text extraction. Have a bunch of people look at these fields, pull the fields out, type them here, and get some diagnostics around this. This did not help with the data structuring problem that they had. And I'm really proud of this one because while you can tell money is an important variable in this, this was the first time I actually saved a person century. So we know about person weeks and person months, and it's a person century. Let me show you how I did that. That's, by the way, 5 million in this in terms of savings as well. So here's a spreadsheet that we were using to track the work that was happening here. We'd start out the first week, we were no good. Now I'm going to put a cost on this of $10,000 per week, okay? By the end of week 4, we had solved 55% of the problem. Sounds good, we're moving in the right direction. The real question is, and this is something the profession has not gotten really good at, is how far should we push this exercise? 55% solved? That's a good, I've invested $40,000 and I've solved 55% of the problem. Not bad, right? Well, we also had lots of data that was not used, 12% at this point here. And this left our problem space, the unmatched problems, to 32%. Everybody okay with going further on this? Makes sense to continue investing, right? Absolutely. So we'll go another 10 weeks, and now we've solved 90% of the problem. Good stuff, right? But now we're starting to get what we call diminishing returns. We're getting less out for each 10,000 we put in. But we can measure that, how we're looking at it. They said if you can find one more set of airplane parts on this, going from this 9% here down to 7.5%, we'll consider it a really good investment. Because our data that we could ignore, 1 in 5 data elements in that database, absolute rubbish. Don't keep them at all. Good. And we've managed to solve 70% of the problem. Now, again, I don't know about you all, but this is where graphs really help. This was the size of the original problem, and this was the problem that now needed to be done manually. Which one would you rather do? And we were pretty certain as to the results that we had achieved here. We could verify these results on a regular basis. So where do I get my person century from? Well, again, spreadsheet. By the way, NSN is like a stock keeper's unit. It's an item, right, in this case. And we said 5 minutes to clean each piece. So there's the total number of time. How many weeks do we work in a year? How many days do we work in a week? How many hours in a day? Again, blah, 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 right? Put it all up there on the thing. So I need, in this case, 10 million minutes to clean the whole set of data, which is 92.6 person years. There's my person century. And the total cost for this was $5.5 million. Everybody follow my math? Not hard, right? Again, these are things you guys can do very, very well yourselves. So let's put in the new numbers under the revised plan. Now I don't need to clean 2 million units. Now I only need to clean 150,000 units, which means now I change these numbers. Now instead of 90 person years, I need 7 person years. And again, cost of 420,000 minus 5.5 million, there's $5 million. Now, by the way, some of you can already figure this out. What's the most important number on this chart? Anybody think you can fix a data quality problem in 5 minutes? Absolutely. Who said it? Michelle. Oh. Can anybody fix a data quality problem in 5 minutes? Okay, if not, if I double it to 10 minutes, what does that do to my numbers?
But still, 5 minutes is fine, right? So you can help to fix that stuff, so you can do that stuff in 1 minute.
Got to absolutely do it. If I double that 5 minutes to 10 minutes, it's 2 person centuries and $10 million. By the way, anybody know what the actual number should be probably? Closer to 1 hour. So the numbers go way, way up from there. This is a little bit of social engineering. If you do this in real time with your groups, your managers will have a aha moment, right? We're looking for that. We'd like to have those kind of aha moments. Now, of course, it's not always about money, although money is a good thing that most managers pay attention to. I also work in my university is the 4th largest medical research facility in the United States. And if they are, for example, our government calls up and says, hey, if you have 20 patients with ear cancer, I don't think ear cancer exists, I'm not a physician, right? But if you have 20 patients with ear cancer, we'll give you some money to study ear cancer. Universities are all about free money and taking things that way. But at the time, in order to find whether we had patients with ear cancer, we had to go through the medical files, the physical files. And who had to look through them? The physicians, the most expensive resource we have in the entire organization. And they're taking their time and they're looking through these files. It took them a month to answer the question, do you have 20 ear cancer patients? Not a good use of their time, right? We certainly would want to do better than that. So putting together, again, from a data perspective, we're able to go in and integrate the existing databases so that we can have lots of integration, eliminate the inconsistencies that were there, cross-analyze these things, and most importantly, double our productivity. We used to be able to match 3 and 10. As a result of doing these exercises, we can match 6 and 10. Transfusions, transplants, all sorts of medical perspectives that came out with better results around that. Again, I mentioned the other piece. Here's a instance where our own US military, we had a piece where we were lighting up a target with a laser pointer. Right? Good. Point it, break that thing, right? That's really the mission that they got in order to do that. And then the batteries died on the unit. So you take the batteries out and put the new ones in. Guess where the laser pointer is now pointing? Not over there, right, where they're looking. Instead, it's pointing right here on our forehead. And we dropped our bombs on our own guys. Not good. These are simple things, but we should never allow a system like that to be fielded with that kind of risk associated with it. One of the most important projects I've worked on was something called our Military Suicide Prevention Project. For some reason, in our military, more of our soldiers die by hurting themselves than bad guys hurting them. That's a terrible thing, and we'd like to fix that. We've been working on this problem for a long time. We have not really managed to get a good fix, but I was involved in the first piece of that, putting it together. So again, lots of things important about this, good mission as far as doing that. We started to pull together various risk factors. It turns out history and things are kind of important on that, what happens to them actually in the military. We started looking at the actual data structures that kept them all together. It was very confusing, took us a long time to figure it out in there. We started to learn about various acronyms and different parts of where things were stored. You have to be quite expert in order to do this kind of work in here. And I ended up with a room, once again, very much like this, where I had my council of colonels. Okay? There are a whole bunch of colonels in the armed forces who would come forward and say, yes, under this circumstance, you can use my data for this purpose. And under this circumstance, you can use my data for this purpose. And we put all of those into a 30 by 30 matrix. Scary, right? If you ever tried to work, yes, so Colonel X would stand up and say, I'm row 13, and you can put a check mark here, and a check mark here, and a check mark here. We're not making progress. This is very slow, but we're trying to follow the rules. And I had the ability to ask a favor from somebody who was a very high-ranking person, the Chief of Staff of the Army. And I brought the Chief of Staff of the Army into the room, who watched what we were doing and saw we were trying to manage from a 30 by 30 matrix. And you know how when they make a decision, they take their portfolio that they have and they put it down on the table very loudly to make a point? He slams his thing on the table here and says, okay, from now on, we're going to call this my data. It's not your data, it's my data. And anybody that wants to tell me why they can't use my data to save my soldiers' lives, here is my office door. Please come and see me. Then he said to me, I'm probably not authorized to make that statement, but it's the right thing to do. More importantly, he told me I could write it up and put it in a book as hopefully inspiration for you all. I've told this story to more than 100 corporate leaders, and not a single one of them will say this. No, these guys still own this data, and these guys still own this data. Even though when I tell the story, we're doing this to save lives, they're chicken. If you can find anybody in your organization that will make the same statement, all of this data belongs to our organization, and it all is going to be used in service. Again, you may not be saving lives. You may be making things faster, better, and cheaper. It's okay, but I would love to hear your stories because I've been telling this story for years and years, and most corporate initiatives are afraid to make this particular statement in order to go forward. Of course, once he made that statement, we were able to then use the data, find out a little bit more about what's happening in our soldiers' lives. Again, don't try and read these things, but we can, start to find out who they were communicating with. Are there patterns? Are there things we can put on social media, watches to keep an eye for them? Are there buddies? We've had a lot of buddy systems where soldiers are watching each other, and when they, it looks like you're having a tough day today, right? We can start to intervene and prevent these things, find out what's actually happening, and come up with this. So this is the end of my talk. Have I given you all some inspiration here to think about different ways of taking your data and helping it become more effective in your organizations? Have you also seen perhaps some ways of inspiring others in your organization to work cooperatively with you so that you and the business can partner on activities to help the organization on the whole? Because we can't do it by ourselves, can we? Right? We're just the data people. We need that cooperation with everybody else in here. And if that's the case, I have a bunch of books on this that may be helpful to you, including a brand new one just came out last Monday on ethical data monetization. In that case, my work here is done.